Sometimes when a student is struggling in grade 1, and by the way, almost all students are struggling in grade 1, so this is a real way to teach problem solving. So what you can see in this sheet here is that this student has got two different colors. And so what happened is that the student didn't finish them all at once, and then mainly the student was struggling with 8s and 9s. And so we just reviewed and played the power of 8 game and the power of 9 game, and then went back to the questions. And similarly, so I'd take the, I would say to the student, okay, let's look at this question, 7 plus 8. What do you do in the power of 8 game when you get a 7 and an 8 up? And often the student may do one of two things. The student may take the card and flip it like this. You try to get them to use their language to say, well, I take these two and put them over there. Why do you do that? I said to Sam. Well, because I want to make a 10. And sometimes we have to have the 8 that looks like this, and then we want to get a 7. And let the student actually physically move the 2 over here. Then we put these aside again. These can be the cards can either be on the board, or they can be, you can, in some cases, put them at a student's desk, but I never put them at a student's desk when they're starting, or they use all of these to count on. So basically, these are a model. We're using a model to help us figure out how to solve a problem. And by the way, one of the other things we're doing is we're looking for a pattern. And we're starting to use our language skills to do this. So basically then, one of the things that we did here is that here Sam was adding 4 to 8, and I drew a little arrow in to show that the 2 was going over to the 8. Then when he did it for 7 and 8, he didn't need it, 5 and 8, so you go around and do all of those patterns. Here, when I was looking at 4 and 7, we discussed the rule, do you do 4 and 7, or what is the difference so we get 4 and 7? And do you do 4 and 7, or do you do 7 and 4? And you see, counters don't distinguish between it, but they often get lost on their fingers when they're doing 4 and 7. The other problem is, of course, we don't have 11 fingers. So basically discuss that I'm looking for the pattern, or you always add the biggest one first. Here is where we made a connection to a double. Doubles in the power of 10 system are really quite easy. If you look at 7 and 7, you can see that the easiest way to do that is to look for the 2 5s. And that's the power of 5 game helps you learn how to do that. So you have the 2 5s and the 2 2s. And so in this case, I noticed that Sam knew 6 plus 6. So I drew an arrow for him and said, well, how would you do 6 plus 7? Again, that's an excellent one to show on here, where you do 6 and 6. And you say, well, now, how do you make 7? Put one more in. How do you do 6 and 7? This physicalness really helps some kids. So what you're doing is roaming around the room, and you're dealing with kids either in small guided math groups. Now this could be a guided math group instruction while the rest of the class is playing a power of 10 game. And so basically, we are trying to personalize and individualize the instruction.